So hello everyone, welcome to OneClass YouTube channel. My name is Devansh and today we are going to go through a couple of popular mathematics question and answers. I'll just give a brief introduction or just a background about myself. So I am in the final year of my graduation and I'm doing my graduation in aerospace engineering. And if you need any homework help or if you need any tutoring help or one-to-one live sessions, then you can check the links in the description below. So without wasting time, let us just move towards our question. First, we have question number one. It states that what is the limit as x approaches infinity of arctangent? We need to find the limit of x limit of x as arctangent tangent inverse approaches to infinity. So for this, we must remember the basic trigonometric ratios of some popular angles. So I remember the trigonometric ratio of tangent of 0, 30 degree was 1 over 3, and tangent of 45 degree was 1, tangent of 60 degree was root 3, then tangent of 90 degree was it was not actually infinity, it approaches to infinity. So I'll just, here it is exactly 0, but this case is approaching to infinity. Now what I will do, I will take tangent inverse on both the sides. So if I take tangent inverse on both the sides, then I will get 0 equal to tangent inverse of 0. I will get 30 degree equal to tangent inverse of 1 over root 3. Then I will get 45 degree, which will be tangent inverse of 1. Then I will get this will be 45, 60 degree. This will be tangent inverse of root 3. And then finally we have 90 degree, and it will be tangent inverse of in. Now we can clearly see that if we go at the tangent of 90 is infinity, then we can clearly see that 90 degree is equals to tangent inverse of infinity. Now what our question says that what is the limit of x as arctangent or tangent inverse approaches to infinity. Now we can see here that this should be an approaching sign. So, or we should write this like, because it is never touching infinity, it is approaching to infinity always. So we can write like tangent inverse of x where limit x approaches to infinity. So we can see clearly that when tangent inverse of x is approaching to infinity, where tangent inverse x is approaching to infinity and where x is approaching to infinity, then we can say that this angle is 90 degree, or we can also say that it is pi over 2. Now let's see the solution given by junior tutor. So here they have given the solution using graphs. So we all know the graph of uh, tangent of x. With this graph, we can clearly see that at 0, in this y-axis I have tangent, and in this x-axis I have the angle. So we can clearly see that at the tangent of at 0 degree, the tangent is also 0. We can see that it. I'm not sure that pi by 4 will be approximately pi over 2 will be 1.5. It will be 0.75. So at say somewhere here and somewhere here, we'll have tangent of 45 degree, which will be equal to 1. Then we can see the graph is not for this part of the graph or this part of the curve, the graph looks like linear, but as it crosses this line or this point, it is kind of non-linear graph. So we can clearly see that as tangent or as my angle reaches to pi by 2, we have an asymptote, and then the tangent of pi by 2 is approaching to infinity, but the property of asymptote is that it is never equal to infinity. So here we can see that we can observe that the limit as x approaches to pi by 2 is infinity. Since arctangent is the tangent inverse function of tangent, we can swap these values. Therefore, limit x approaches to infinity, arctangent of x equals to pi by 2. The same kind of solution which we did here. So this is one method. We can do it analytically or mathematically, or we can um, do it with the graphical method. So in this case, we have successfully found the solution, and the solution given by Junior Tutor is correct. So I will just say correct solution. Great job. Now we have another page, question number 2. I'll just use the black. So we need to solve sine negative of pi over 2. This is sine negative of pi over 2. So for this, I'll use the unit circle, and I'll just draw the axis. Let's say no. Let's say one axis is this one. Let's say I'll just draw it. Now, I don't know if you know the property of angles or the sign notation of angles. So when we move in anti-clockwise direction, then we take it positive, and when we move in clockwise direction, we take the angles as negative. So here we can see that this is pi over 2, 0, this is pi, this will be 3 times pi over 2, and this will be then 2 pi. Now we can see that for sine of pi by 2, at this point the coordinates of unit circle is 0, 1. I need coordinate for this point will be 0, negative 1. Okay. Now we can see that we need to go or we need to travel the pi by 2 degrees from positive x-axis. Now here we can see that we have a negative sign. So instead of going in anti-clockwise direction, we need to go in clockwise direction. If we go in clockwise direction, then my pi over 2 will be nothing but this point. So at this point we can see the angle is given as 3 pi by 2. So we need to basically find the sine of 3 pi by 2. Now we can also do this mathematically instead of graphical notations. So whenever we have any angle given in negative terms, what we do is that we take, suppose if sine is given in negative angle, this was negative pi over 2, we just add 2 pi, or we just add this whole angle, then we subtract 2 pi from yeah, then we subtract the angle from this whole 360 degree, so that we get the positive value of angle. So instead of going in anti-clockwise, instead of going in clockwise direction, we will be going in anti-clockwise direction. So it will give, I will take LCM, so 2 to 4, 4 minus 1, this will be 3 pi over 2. So whenever we do analytically, we get the same formula. Then now we need to find the sine of 3 pi over 2, and we know that the sine whenever we want to find the sine using unit circle, then we just need to, so whenever you want to find the sine of any angle, let's say the angle is theta in unit circle, then it is nothing but the y coordinate of that point. So I can write 3 pi over 2, or sine negative of pi over 2 is the y coordinate of this point, and the y coordinate of this point is negative 1. Hence we got the solution as sine of 3 pi over 2, or sine of negative pi over 2 is negative 1. Let's see the solution given by junior tutors. First we need to convert the negative angle to positive, so we already did that. Then the sine function takes the value of the y coordinate of the point. We did the same thing, and the final answer is negative of 1. The solution given by junior tutor is correct. I'll just write correct solution. Good. Now we move towards question number 3. So what is the respective graph for each given logarithmic function? Choose between the given choices. So here we have 4 choices and we have 4 graphs. So we need to just match the correct choice with correct graph. I'll just write this as match correct. Red pen. Now first we'll start with A. In A we have been given as f of x equal to log 2 base 2 and log of x with base 2. Now for this question we'll be using calculator because we don't know the value of log with base 2. I'll just use my calculator for this calculation, and I'm not sure that my calculator. Okay, so instead of doing with calculator, I have another approach also. So let's say this is equal to y, then I will take antilog on both the sides. So I will get x equal to 2 raised to the power y. This is the property of log. So for example, log of b with base a is x, then b will be a power x. Now we have this modified function. I'll just put the value of x as 0. Then if my x is 0, will be equal to 2 power y, and this should be sure, I'm not sure at 0. Uh, this will be infinity. So I shouldn't be using 0, because log of, if I take x as 0, then log of 0 is not defined. No, log of 0 is not defined. So I'll just skip the value for 0. Let's see, in the graph we have been given the values for is given for y. First, I have another approach now. I'll keep y as 0. So when y is equal to 0, then y to power 0 is 1, x is 1. So I have one coordinate. When y is 0, then x is 1, which is not matching with any of the graph. Now we cannot use y equal to 0. I'll just take the derivative. I think if I take the derivative, let's see the solution given by Junior Tutor. They haven't given any proper solution here. So what I should do now, log base 2 for x. I'll just check the derivative of okay. So I will use another approach right now. I'll just convert the base of this log to y equal to, this will be ln of x over ln of 2. Now I will just take the derivative, or instead of taking derivative, I'll just use, I know the value of ln of 2 is 0.693, ln of 2 0.693. I'll just take the derivative to see whether my slope is going to be positive or negative. So this will be 1 over x times 1 over ln of 2, because ln of 2 is constant, and derivative of ln of x is 1 over x. So I can clearly see that the slope is going to be positive. So in this case, we have this one is positive slope and this one is positive slope. This one is negative. This one is also negative slope. So we have option, we have the choice between option 3 and option 4. What I should do is that I should put the value of, I should take the value of y, the 1, and let's see if it is positive or negative, because if I put the value of y as 1 and if my x comes out to be positive, then it will be graph number 3. If x comes out to be negative, then it will be graph number 4. If I put y equal to 1 in this equation, my x will be 2, so it is going to be a positive value. So we can clearly see that with positive slope, this is a positive slope, and for y equal to 1 we have positive x value. So for a, the option is going to be 3. We'll just cross check with the solution given by Junior Tutor. So yeah, this is the correct solution. Now we'll go for graph number B. So for different problems, we need to follow different kind of approaches. For this particular problem, we are going to be using this. First, we are going to convert the log base, and then we are going to find the slope. We'll see whether the slope comes out to be negative or positive. Then we'll just put the value of y as 1, and then we'll see if we get negative or positive value for x. So for B, we have log of x with base 2 minus x. I can write this as y equal to ln of x over ln of 2x. I'll just take the derivative, and ln of x will be 1 over x times ln of 2, 1. So I can clearly see that for this question, my slope is going to be positive. So now we can clearly just proceed with this problem, because for positive slope we have only two graphs. This one was for the A option. So for B option, fourth one is going to be our answer. But I'll just do one thing, that I'll just put the value of y as 1. For this we need to take anti-log. So y was ln of x. I'll just subtract with x ln of x over ln of 2, and then instead of going this, I just use this equation. So I will not use the converted form. The converted form was only for taking the derivative. So this equation, y plus x to log of base 2, log of x with base 2, then my x is going to be 2 power y plus. Now I'll just put the value of this case. It is kind of difficult. I can write this as 2 power y times 2 power x. Now I'll put the value of y as 1. So I will get 2 power x equal to, this will be 2, this will be 1. So this will be 2. Again, I think I have to take log. I hate to admit, but I have to take x equal to 2 times 1 plus x. I will take natural log on both these sides and it will become ln of x equal to 1 plus x 2. Then again I have ln of x minus 1 plus x equal to ln of 2. Oh god, this is very horrible kind of thing. I'll just put ln as 1, or I'll just put x as 1. Um, x as 1, x as 1. If I put log of negative value is math error. Okay, okay, I get. I'll just cross check with the solution given by Junior Tutor. For B, we have graph number 2. How is this possible? Oh God. Okay, okay, okay. I did a mistake here. This function was different. Okay, okay, okay. Now I got it. This was not ln of x minus x. This was log of negative of x. Now it is pretty much easy. I'll just y equal to of negative of x with base 2. Then this implies if I take antilog on both the sides, we'll get negative of x equal to 2 power y. Then I will, for this one, I will write ln of negative of x over ln of 2. I'll just take the derivative here and this will become 1 over negative of x. Then 1 over negative of x. Then we will have derivative of this term also. This will be minus of 1 over ln 2. So derivative of minus of x over ln of 2. So we can see that d over dx is going to be 1 over x times x2, and for y equals to 1, 2 power 1 will be negative of x. This implies x will be negative of 2. So for positive y, my x is going to be negative and here my slope is going to be positive. So this is a positive slope. For y equal to 1, I have negative 2. So for B, graph will be number 4. This is a negative slope. This is a negative, positive slope, positive slope. Then for positive value, I have negative x. C. Pretty much good. For C, I have f of x as negative of log base 2. This will be y will be equal to negative of log base 2x, and taking anti-log I will get 2 power minus 1. equal to x, or this will become or minus 1 or 1 over x. Yep, can do it in this way, or I can write 1. This will become over x will be 2 power. Now for taking derivative, let's just plug in the value for y. So when y is 1, 2 will be 1 x. This implies x will be 0. And talking for slope, so y equal to ln of 2, derivative will be 1 over x 2. So my slope is going to be negative and positive. X will have positive y. So for first quadrant, positive x, positive y, my slope is going to be negative. So for C, my option is going to be 1. Then for last one, D, we have f of x as negative of log base 2 negative of x. So again, we'll go for with the same procedure, y equal to negative of log negative of x. This will become y equal to negative x or minus 1. Here we are using the property of log. So if you don't know the property of log which we are using, again is like log of a with power b will be equal to b times log of a. So we are just using the opposite. Now I will take anti-log. So 2 power y will be equal to 1 power 1 over x. This will be negative. So I'll just put the value of y as 1. So this will be negative of 1 over x. So x will be negative of 0.5. Now again y will be equal to log of negative x. So this will become ln of 2 derivative will give minus x. Derivative of minus x is 1, negative 1, 1 over ln of 2. This and this will get cancelled and we have a negative slope. So for negative slope we have this, and for positive y we have negative x. For positive y we have negative x. So for D, graph will be 2. And the solution given by junior tutor is incorrect because for this one, this will be graph number. For B1, it will be graph number 4. For C, it will be graph number 1. Yep. And for D, it will be graph 2. Solution is incorrect because for B, it will be 4, it has a graph number 4 has a, I think it has a positive slope. Yep, graph number 4 has a positive slope, and for D, it will be graph number 4 because it has a negative. Yep, so we have, this was 1, 2, 3, question number 4. We wasted a lot of time for the previous question. Here we need to evaluate sine of 2 pi by 3. Of 2 pi by 3. So again we are going to take the help of unit circle, and I'll just take red pen. So for unit circle, when we need to find the angle of, when we need to find the sine of say any angle theta, then it will be just y coordinate of that point. Now my 2 pi by 3 will be this one, 120 degree, and for 120 degree my y is, for sine of, for 120 degree or 2 pi by 3, coordinates are negative of 1 over 2 to 3 over 2. Then finally I can say sine of 2 pi by 3 will be the y coordinate, and it will be root 3 over 2. Let's see the solution given by Junior Tutor is correct. I'll just say correct solution. Great job. Solution is correct. We'll go for question number 5. So for question number 5, we need to graph 1 plus cosine of x. So I'll be using the same procedure as used by Junior Tutor. I'll just make a kind of table here. Then we have theta 1, 2, 3, 4, 4 columns. With 4 columns. Now I'll just, let's say that this f of x is y, so y equal to 1 plus cosine. Now So my x will be here, then this column 1, I don't know why they have column 4. Okay. So this will be just cosine x, but it will be the evaluated value. And then we have go for 0, pi over 2, then pi, then we'll go for 3 pi over 2, then pi. So for this will be cos 0, this will be cos 2, this will be cos pi, this will be cos 3 pi over 2, this will be cos 2 pi. Now you can use the calculator here, like it's your choice. I kind of remember these values. For cos 0 it is 1, it will be 0, then negative 1, again 0, and then positive 1. Now for this one we are just going to add 1, so this will be 2, this will be 1, then this will be 0, 1 and 2. So for cosine we have a graph. This the axis, not this. Go for another positive quadrant. I'll just draw a line for negative 1. There is now this is the graph for y equal to cos x. So for 0 we have 1, 7, 0, pi by 2, pi, 3 pi 2, pi. Now for 0 we have 1, then for pi by 2 we have this, then negative 1, this, and positive 1. So so graph of cosine x is basically like a sinusoidal wave, and it looks kind of like this. Now for my drawing is not very good, so it looks a bit ugly, but doesn't matter that basically we know the approach, know the graph of our cosine curve. Now we'll draw the graph for y equal to 1 plus cosine x. And for this one I will have one more line. Yeah, but now again I have 0. This is basically y. So we can see that y is going from 2, y is going from 0 to 2. Well, we don't need it. Well, we shouldn't be needing this axis. I just do it, so just give it. And for x we have pi by 2. Okay, 3 pi by 2, 2 pi. to 3 pi over 2 and 2 pi. So for this will be 2 1 0 1 2. Will be 0. So I will again try for the curve here. So we can see that the graph for y equal to 1 plus cosine of x is going to be looking like this. So the difference between y equal to cosine x and y equal to 1 plus cosine x will be the graph will shift 1 unit upwards. There is nothing significant change. This graph will shift by 1 unit upwards in positive y direction. So let's see the solution given by Junior Tutor. So this is the graph for y equal to cosine x, and we can see 1 plus cosine x will be 1 unit upwards. Then they have, okay, so they have drawn in the same coordinate system or in the same axis, they have drawn both the functions. And here we have the basic explanation. I'll just write this for you. So here they have written y equal to a times cosine bx plus c plus d, where d is the y displacement or increase in amplitude. Displacement a is the amplitude, and then that is pretty much, and then we have 2 pi over b, which is x displacement. Here again, solution given by the solution given is correct. Nice work. Now we have another question. This will be question number 6. Will take my black. It says that we need to find the value of cosine 3 pi by 2 plus x sine 3 pi by 2 minus x. So here I'm going to use cosine of a plus b, which is cosine of a cosine of b minus sine of a sine of b. Then I will use sine of a minus b, which will be sine a cosine b minus cosine a b. So let's just use these identity and expand this. So this will become cosine 3 by 2 cosine 3 pi by 2 sine x, then this will be plus sine 3 pi by 2 x plus cosine 3 pi by 2 x. Now cosine 3 pi by 2 is nothing but cosine of 3 pi by 2 is 270 degree. I'll use my calculator. 3 pi by 2, yeah, it will be 270. So cosine of 270 will be 0 and sine will be, I think, -1. Yup. So cosine will be 0 and sine of 3 pi by 2 will be -1. So we'll just substitute these values back into this equation. 0 into cosine -1 x plus we have -1 cosine x 0 times. So this will be 0. This will be sine. This will be cosine. Now let's see. Okay, so we'll be ending this point or at this step. So it was just pretty much easier. We needed to just use the basic trigonometric identities, which is summation of angles, and we just expanded it using those identities, and we just put the values, and at last we have sine x minus cosine x. And here also the solution given by Junior Tutor is correct. Solution would work. This was question 6. We'll move to question number 7. So in question number 7, it is asking what is the recursive formula of geometric series, geometric sequence. So I'll just say recursive series. Now I'll just say GS for geometric series. So geometric series is like the first term we have A1, then first term is A1, then we have A2, let's say to second term, then we have A3, third term, A4, fourth term, to continue till AN, which is nth term. Now for this one we have A1, we can write this as, so A1 is just going to be A1, my A2 is going to be A1 into R, then third term will be A2 into R, fourth term will be A3 into R. So geometric series is basically we have a common multiplier which is R, and then we multiply that common multiplier with the previous term to obtain the current term. And this will be for AN, will be AN minus 1 into R. Now I can say that A1 is basically A1 is just A1, then A1R is A2, so I can put the value of A1R here in the place of A2, so this will become A1 into R square. Now if I put the value of A3 in this term, then A3 is A1R square, so A3 will be A1 cube. And then we have for an, so for an minus 1, it will be A1 R power. This was my total power will become a, just cross check, minus 1. So hence we have the geometric series as A1, A1R, A1R square, A1R cube, and for nth term we have A1R n minus 1, and this formula, or to calculate the nth term, we have an equal to A1 r power n 1, and this equation is called the recursive formula. So recursive formula is nothing but to calculate the nth value of a geometric series. We have a simple formula which is an equal to a1 times r power n minus 1. So solution given, correct, nice work. We have one more graphical question. Question number, we need to graph x, y equal. I'll just rearrange this equation in terms of y. This will be y equal to x minus 2. So this is a graph like y equal to mx plus c, where c is going to be my y-intercept and m is going to be slope. Now we can clearly see that slope, if in this equation the slope is 1 and y-intercept is negative of 2, so tangent inverse of 1, because my slope is nothing but tangent of theta, which is m, therefore tangent inverse of m will give the angle for the straight line. This equation is for straight line, so I will write tangent inverse of 1 is nothing but 45 degrees. So we need a coordinate system here. We'll be needing for the one with all the 4 quadrants. And then take this color. This is y, this is x, 0. Let's say this is 1, 2, 3, 4, 1, 2, 3, 4. for y-intercept we need this point. Then we'll just draw a straight line with 45 degree of angle. This should be 45. I'll just pick this line. It is very difficult to just, yeah, finally. Now I will just extend this line further. Oh my god, no, 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 no. Yeah, and I will just draw the arrow here and one arrow here. So this is going to be the line, and we can just calculate where x is 0, where y is 0. I'll just put y equal to, what was the equation? X minus 2. So when y is 0 minus 2, so x will be 2. Y is 0 when x is 0. So this will be 2. Let's see. So here they are calculating the intercepts first. And we have also obtained same graph. So this was the equation of a straight line, and these kind of equations are very easy. We just need to convert it into a general form and we can find the slope. And the slope was also very easy. It was just 45 degrees. And that is pretty much solution. Work. This one is still loading. I'll just look at this. Back. Okay. This was question number 8. We have question number 9. We need to graph y equal to x cube and y equal to 16 over x on the same set of coordinate axes. Use the graphs to find the exact solution to the equation x cube equal to 16 over x. Verify by substitution that they satisfy the equation. So we have y equal to x cube and we have y equal to 16 over x. So we need to draw these graphs. First, we'll take the coordinate axis here. We'll copy this and paste it. So this is going to be for y equal to x cube, and this is going to be for y equal to 16 over x. The red pen. I will just find few coordinates. First 0, 1, 2, 3, 4, 6. 1, 2, 3, 4, 6, 3, 4, 6, 7, 1, 2, 3, 4, 6, 7. I'll be needing 8 and 9 also here. 8. So let's just find few values for this y equal to x cube. So for y equal to x cube, I have I'll just put x as 1 as 0. So this will for x as I'll put -3, then this will be -9 to negative. Okay, okay. This is cube, not square. I got confused. So for -2, I have -8, -1, -1, 0, 0, 1, 1, 2, 8. And for y equal to 16 over x, I have x. For x cannot be 0 here. So we can clearly see that when x is 0, my y is going to be infinity. So this y equal to 16 over x is going to be discontinued as at x equal to 0. Let's just see, we have made the discontinuity here. Okay, so this is the curve of I think this is hyperbola. So I will just put the value as let's say for -1, we have -1. What are the intercepts they have taken? Let's just put for -5. Then they have chosen y as 16. So x as 1, y will be 16. X as 2, y will be 8. Then x as 4, y will be 4. Then let's say x as 8. Then we'll have y as 2. And x as 16, y as. I'll just draw one more here for negative terms. So for -1, we have -16, -2, -8, 4 minus 4 minus 8 minus 2, 16. So first we'll go for y equal to x cube. So for -2, we have 8. So this is minus 2. We have 1, 4, 5. This is going to be 1 point. Then minus 1, we have 1. So this is going to be another 1. Then for 1, 1, for 2, and it comes somewhere here. Now I'll just cross check. So it is going to be like this, then here like this, so this. Oh god, this one is very difficult. 2, 3, 4, 5, 2, 3, minus. We have minus 1, minus 2, 3, 4, 6, 3, 4, 5. So suppose if we have a graph paper, then these curves are going to be look much more better and accurate. Minus 2, minus 8, so 2, and we have 8, 6, 7. For 2, we have this 8. Then for a column 2, we have 1 by 6, 2 for 8, okay, 4, 4, 8, 2. So 4, 4, 8, 2. Then again we have 2, it is 7, 8. Then we have 4, 4, 4 and 4, and 2 and 8 will go like this, and it will go like this. Okay, so now for finding the solution or the intersection coordinates, what we do is that we have one equation which is 16 over x. We have another equation as cube. We'll just substitute the value of y in this equation. So we'll have x cube as 16 over x. This implies x power 4 is equal to 16. This implies we have x as x square will be plus minus 8. When x square is plus 8, x will be 8. When x square is negative 8, x will be imaginary. So for negative 8, it is not going to exist. These are going to be imaginary values. So for x equal to plus minus 8, I'll just put these the value of x equal to plus minus 8 into this equation. So for x equal to plus 8, we have y equal to 2. For x equal to negative 8, we have y equal to negative 2. So two sets of intersection are 2 comma 8, sorry, 8 comma 2. This will be 8, 2. This will be negative 8 comma 2. So 2 comma 8 and then negative 2 comma negative 8. Okay. So, well, we cannot do this thing here, but finding the solution graphically means first we need to have proper grid system and proper graphs, which we don't have, which I don't have here. Then we are going to superimpose, or we are going to draw both these graphs on the same coordinate system or the same axis. Then finally we'll get the value of intersection points from graphical method. But when if we don't have the proper graphs, then we can just use these mathematical formulas to calculate. So solution given here is correct. Given correct. Work. So this one is going to be question number 10. It states that how do you find the exact value of tangent of pi over 4? Tangent of pi over 4. Well, to calculate tangent of pi over 4, we have many approaches. We can first use trigonometric, we can first use unit circle. Then second one, we can just use the calculator. Then third one, we can use a right angle isosceles triangle. So if I draw a square, then if I draw one diagonal, this square, then I will erase this part. Then I know that this angle will be 90 degree, this will be 45 degree, and this one will be 45 degree. And as this is an isosceles triangle, so let's say these sides are equal, which is A. So using Pythagoras theorem, we can calculate h, which is hypotenuse, and it will be h square will be a square plus a square to a square, which will be 2 times square root of 2 times a, 2 times a. Now tangent, well, we shouldn't be doing this because we don't, for tangents we don't need the hypotenuse, we just need the opposite and adjacent side. So tangent of theta is theta, or cosine of theta. Then we have tangent of 45 and 45 over cosine, or we can say tangent of theta is opposite over adjacent, and for this triangle we have tangent of 45 and a over a, which is 1. Or we can use the value of sine 45 will be adjacent over not adjacent, opposite over hypotenuse, which will be 1 over a over square root of a will be 1 over square root of 2. Cosine 45 is adjacent over hypotenuse, which will be a over root 2. This will be again 1 over root 2. Then tangent 45 will be sine 45 over cosine. This will be again 1. So here we can see the solution is in the similar manner. We have used a triangle here, and they already knew the value of sine 45 and cosine 45. So there are numerous methods of calculating trigonometric ratios, but the best one is either you remember those values of some common angles, or you just use the unit circle. So the solution is correct. Good work. Again, we have one more trigonometric question. This was question 10. This is going to be my question number. We need to find the exact value of cosine pi over 3. So cosine pi over 3 is nothing but 60 degree. So we need to find cosine of 60 degree. So let's see the kind of approach they have used here. Then we get cosine of the angle in degrees. We will have, so they have just used the direct method. Directly we can say it is 1 over 2 or 0.5. But if you don't remember the value of cosine of 60 degree, what we can do is that we can draw an equilateral triangle. Then we can draw one line. I will just keep this line. I'll just draw another line. Draw one more line. This is going to be, let's say this is the bisector line or height of that equilateral triangle. Then for an equilateral triangle, we have equal sides. Now for equilateral triangle, we have the property that if we draw a bisector, or if we draw perpendicular from one edge to the other side, then that perpendicular bisects the other side. So this will become a by 2, this will become a by 2, and this is 60 degree. This will bisect the angle, so this will become 30, and this we know is 90 degree. And then we can just use the Pythagoras theorem to calculate this height. This is height, not hypotenuse here. So for calculating the, or basically we don't even need the height for calculating cosine. Cosine is, which is adjacent over hypotenuse. Let's say this is A, B, C, C. So this will be CB over AB, and my CB is A over 2 times 1A. This will be 1 over 2 or 0.5. For calculating sine, we can just use the Pythagoras theorem to find the height, and then we can um, write opposite over hypotenuse. So the solution given by Junior Tutor is correct. Great work. Again, we have a graphical question. This is question number 11, and this will be H. Question number 12. We need to graph y equal to negative of ln of x. So y equal to negative of ln of x is basically y equal to negative of log with base e then x. So for graphical method, we are just going to use, it is better that I take the antilog here. So first I'm going to use two properties of log. Log of base a with e, b will be, it is equal to y, then b will be a power y, and another property will be log of b power a equal to c. This will be c equal to 8 times log of. So here we can see I'm going to use these two properties. First I will take the antilog by using this property. No, first I will use the second one to take this minus 1 in the power of x. So this will become ln of power minus 1. This is nothing but ln of 1 over x. And then I will take the antilog using this first one. So this will become e power y equal to 1 over x. Now this graph is going to be discontinuous at x equal to 0, because if x is equal to 0, then this term will become infinity and this will be. So I'm going to calculate few values for x and y. So for x equal to 1, we have yeah. So I will just put y equal to 1 here. So when y is 1, I will have this e is 2.71, 2.71 into 1 into 2 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 Where is my cursor? Here. Okay. E will be 1 over x. Then I will just multiply x on both the sides. X will be 1 over e. So x will be 1 divided by e, and this will be 0.367. Then for y equal to 2, I have e power 2 equal to 1 over x. This implies x will be 1 over e. So this will be 1 divided by 0.135. For 3 again we have 1 over e power 3. 0.4 point, no, not point, 0.049. And let's just take the value as -1. I'll just see these values given by a junior tutor. Okay. So they have drawn figure. First line is for y equal to ln of x in blue, and red one is y equal to negative of ln of x. I can take the value if I take let's say if I take y as 0, then this will be e power 0 will be 1 over x. This implies x will be 1. Okay, so we have a couple of coordinates with us. Now we are going to plot these coordinates. So I will use this one first. Straight line. Let's just leave it like this. This is y. We have some values for negative also. When y is -2, I'll just write when y is -2, we have power -2 equal to 1 over x will be e power when y is negative, x is going to be first I'll just draw with 0 only because I'm not sure about the values here. So 0 for y we have 0, 1, 2, 3. 2, 3. For 0 we have x as 1, Now for y equal to 1, I have 0.36. Let me just cross check this solution. 1 over x here will become 1 over x, and e power y will be 1 over x. For y equal to 1, x is 0.36 to 1, x 0.36 equal to 1, my x is 0.36 is somewhere here. For that, the graph of y equal to negative of ln of x will be, okay, so this was for red. Okay, I thought the blue one is ln of x. That's why I was getting confused. So we basically need the values for negative also. Okay, yeah, right. I'll just write e square 7.38. Then for y equal to -3, we have e cube 20.085. We do not have 20 in our x-axis. So for 0, my y is 1. For y equal to 0, my x is 1. So this will be here. Then I will use these values. So for y equal to -1, my x will be e will be 2 point black pen 2 e 1, it will be 2.7 somewhere here. Then for 2 it is 7.38. 7.8 will be somewhere here. So this way will be an asymptote here. This will go like this. So it is going to be the red line here. And that is pretty much all for this question. So again, correct solution would work. Solution is correct. Okay. Just a moment. I think my video is freezed. I just so I don't think that my video is working. I I don't know. It got freezed. So So that is pretty much all for this session. And if you like this session, then you can hit this like button and subscribe also. And this was Devansh Purohit, senior tutor at OneClass. And if you need any homework help or if you need any tutoring help or one-to-one live sessions, then you can check the links in the description below. And you can also subscribe or hit the bell icon to get to be updated for our next live streams. And that is pretty much all for this session. So I hope to see you soon in my next video. So till then, bye.